Good afternoon, friends. Welcome to my YouTube channel. Myself, Dr. M.H. Annaya. Friends, in today's video, we are going to learn about the section of a square pyramid which is resting on one of its corners of the base on HP such that the axis is inclined at an angle of 40 degrees to HP and it is being cut by a section plane which is normal to VP and it is cut at a distance of 30 millimeter from the base of the solid. This is 30 mm. So friends, we are required to draw the sectional top view, front view and true shape of section. Now let us read the question for today's video. It reads as a square pyramid of side 30 mm and axis 60 mm long resting on a corner of its base on HP with the axis inclined at 40 degrees to HP. So friends, whenever you find this term that the pyramid is standing on HP on a corner or it is resting on a slant edge or the slant edge inclined to HP, keep the pyramid on HP such that two of the base edges are equally inclined to VP and you will be able to see these two rectangles in the front view. And in the top view, you will be able to see the vertex and all these four slant edges connecting the vertex to the edges of the base. So friends, I have kept the pyramid here with two of the base edges inclined at 45 degrees to VP to the given size of 30 millimeter. This has got a dimension of 30 mm. And after this, we are going to obtain the front view. The height of the front view is given to be 60. So by projecting all these lines from the corners, you will be able to obtain the triangle O dash, A dash, C dash, which represents a front view of the solid. Friends, let us name these corners as A, B, C, D, and in the front you will see them as A dash, B dash, D dash, C dash. This is the axis O dash, O1 dash. And in the top view, friends, OA, OB, OC and OD represents the four slant edges of the pyramid and O1 is the center of the base. Now friends, you find that in this position, you find that the axis O dash O1 dash is normal to HP, axis perpendicular to HP. And this is the case with all the solids, whether it is a pyramid or a prism, a cone or a cylinder. Whenever it is placed on HP, on its base, the axis is perpendicular to the HP. Now in the question it is said, it is cut by a section plane by a SP means section plane inclined at 50 degrees to HP and at a distance of 30 millimeter from the base of the pyramid. So this is the base of the pyramid. You can take 30 millimeter and draw this line. So friends, I am going to obtain this figure 1 here as figure number 2. Only the difference is that the axis was perpendicular. Now it is made at an angle of 40 degrees to HP. Now the section plane is cutting this solid in this position and this section plane is inclined at 50 degrees to HP. Friends, generally when the object is inclined to the right, the section plane is inclined to the left. We take it as inclined to the left. And one important thing here is, friends, the base here, this is section plane SS, and you can find, friends, this section plane is drawn parallel to the base, and in other words you can say that the section plane is parallel to the base of the pyramid, and hence in the true shape, whatever the base shape you have got, similar shape you are going to get here. So depending on the position of the section plane, you are going to get a square, a perfect square in the true shape of the section. Now friends, I have drawn this section plane here parallel to the base A dash C dash, and we get all these points before writing the section plane. This is the initial position of the solid, and let us see where all the section plane is cutting. Section plane SS is cutting this O dash A dash here. I write a vertical line from there till it touches this O A, and we obtain this point here. This is our point 1. Say on OA we have got 1. Similarly, friends, this section plane is cutting OB, that is O dash B dash, and O dash B dash at this point. Similarly, I draw a vertical line from there to cut O dash D dash and O dash B dash at point 2 and 4. Finally, the slant edge O dash C dash is cut here. I write a vertical line from there to cut that O dash D dash. That is, sorry, this OC at this point 3. So friends, we have got all the three A, B, C and D. All the four slanted are cut here, and we have finally the 4 points joined here by straight lines, and I am going to section it by lines drawn at an angle of 45 degrees to the horizontal. After this, friends, let us see what is the portion that is left over. So this edge is visible, this is visible, whereas from O to this 1, 2, 3, 4, this is 2, 4 and this point is 3. This is the sectional top view as a whole. So we call it as sectional top view. And friends, these edges from 4 to D, 1 to A, 4 to D, 1 to A, 2 to B, 3 to C are retained, and hence I have shown all these by straight lines. After this, friends, here the point C is not visible to the observer in the top view, hence the lines connecting that, namely this point, that is AB, C to D, C to B, are shown by invisible lines or dotted lines. Friends, this complete figure in the above the XY line will give you front view FV of the solid. This is the sectional top view of the solid, and we have been asked to draw the projections including true shape. What is the true shape of the section? Friends, whenever you hold a mirror parallel to the section plane anywhere after this, whatever the image you get in the mirror is the true shape of the section. And as I have told before, since the section plane is parallel to the base, the true shape you get here across this section is going to be a figure similar to the base. This base is a square, and hence in the true shape you are going to get a perfect square. And in fact, if you are asked to find out the dimensions of that square, you can simply measure either 1, 2, 2, 3 or 3, 4 will give the size of the true shape of the section, which is a square in this case. Friends, I hope the presentation was interesting. Please go through the complete video. Do not skip anything in between. And if you like this video, share this video with all your friends without fail. Have a wonderful day.